This is a practical demonstration of the charging and discharging of capacitors. We have a variable DC power supply which has a positive and negative terminals. We have a filament lamp rated at 6 volts, and most importantly we have a 160,000 microfarad capacitor rated at 10 volts DC. The capacitor has positive and negative terminals. This is the positive terminal and this is the negative terminal. The first step is to check that the capacitor is fully discharged. So we will connect a lamp across the capacitor. The lamp is not illuminating, which tells us that the capacitor is fully discharged. The next step is to adjust the DC power supply to around 6 volts. Then connect the positive terminal of the power supply to the positive terminal of the capacitor, and the negative terminal of the power supply to the negative terminal of the capacitor. Always make sure that the positive terminal is connected to the positive terminal and the negative terminal is connected to the negative terminal of the capacitor. Otherwise, the capacitor might explode. Now, the capacitor is charging. It takes time to charge for only a few seconds. Now, we will switch off the power supply and disconnect the capacitor. The capacitor is now fully charged and acts like a battery. We will connect the capacitor to the lamp. Let's observe the lamp while we connect the other terminal of the capacitor to the other terminal of the lamp. The lamp is illuminating, but the illumination is decreasing, which tells us that the capacitor is being discharged by the lamp. Now the capacitor is fully discharged, so we can charge the capacitor again. The last step is to observe the charging current of the capacitor. So we will connect a lamp in series between the positive terminal of the power supply to the positive terminal of the capacitor, and the negative terminal of the power supply to the negative terminal of the capacitor. The power supply is turned on. The lamp is illuminating, but the illumination is decreasing, which tells us that the capacitor current is decreasing exponentially. Now the lamp is off, and the conclusion is that the capacitor is fully charged, and the capacitor voltage is equal to the power supply voltage, which is 6 volts. The capacitor voltage increases exponentially. This is a brief explanation of the theory of the charging and discharging phases of the capacitor. We will start with the charging phase first. This is the electrical circuit of the charging phase. This is the power supply voltage, which is 6 volts, and this is the capacitor with the positive and negative terminals. The capacitor voltage is VC and its current is IC. Now this is the curve of the charging phase. the capacitor voltage charges exponentially until it reaches the battery voltage, which is E6 volts, whereas the current decreases exponentially, and this is IC from E over R, and this is the capacitor voltage VC. The circuit has a time constant tau, and the final time is 5 tau. The equations are VC is equal to E 1 minus E minus T, which is this one, the time in general, over tau, whereas IC is equal to E over R, E minus T over tau. This is the discharging phase. We have disconnected the charging circuit, and we have connected a lamp across the capacitor. When we switch on the switch to the lamp, we will have a capacitor current and we will have a capacitor voltage. So if we draw it, this is what we see. The capacitor voltage is decreasing from volts E because it was charged to E, and the current also discharged from E over R. So this is IC and this is VC up to 5 tau. The equations are VC is equal to E minus T over tau. E is exponential. IC has changed its polarity, so it will be minus E over R, which is the resistance of the lamp, exponential E minus T over